All right, everyone. Thank you for joining us today for our 3D surface fuels and vegetation modeling prize challenge virtual information session. Let me share my screen here and we'll go ahead and get started. All right. So once again, thank you everyone for joining us today for the 3D Surface Fuels and Vegetation Modeling Prize Challenge. Today, we're going to be holding our virtual information session. So it's a great opportunity for all of you to ask questions and learn about our prize challenge process, as well as our specific problem statement and solutions and outcomes that we're looking for. My name is William Osorio. I'm one of the project managers here at the Tech Rove. And on behalf of our entire team, we're thankful for you for joining us today and very excited about your interest in this prize challenge. Um, Before we jump into the presentation itself, I just wanted to let everyone know that this session is being recorded. We're going to record this and use this as an opportunity for you to be able to reference this later on. So we're going to be posting the link to this recording on our challenge page. So you'll be able to access it as we move forward in your submission process. So this will be a resource for you to use as we move forward in the prize challenge. So thank you for that. Our agenda for today. So our agenda is going to be broken up into 5 different sections. The first thing we're going to cover today is an overview of the Central Florida Tech Rove. So who we are and what we do. I'll give you a little bit of a background on that. From there, we'll shift gears and we'll move into the specific prize challenge problem and then the solution. So we're going to go into detail and describe exactly what we're looking for there for this prize challenge. Third, we're going to go into an overview of the overall prize challenge process itself. So what you can look for in phase 1, phase 2 of the prize challenge. We'll talk about key dates and reminders. So we'll talk about the timelines that you should be aware of and really mark down your calendars. And then we'll wrap up with a Q&A session. So you'll be able to ask any questions that you have just from the knowledge that we covered today, the information that we covered today. And if there's any more technical questions that you might have, we also have some of our subject matter experts here online with us today that'll be able to weigh in on those as well. Guys, if you can please mute yourselves. Thank you. All right. Okay, so the Tech Rove. So if you are not familiar with the Tech Rove, or maybe this is your first time joining us today, the Tech Rove is really an innovation hub. So we connect industry, academia, and government to help rapidly solve real world challenges, right? We do that through several tools. Number one being our powerful network. We have a nationwide network and strong relationships all over the nation and even here locally in Orlando, Florida. So we use that network to our advantage to help our government partners, but we also have specific tools like tabletop exchanges, tech scans, and in this particular case, prize challenges, which we use to uncover and identify innovative solutions quickly, right? So our goal really is to help our government partners and help to connect great people, great ideas, and emerging technology to help drive innovation forward, right? So that's kind of what we do here at the Tech Rove. If you want to learn more about what we do and how to work with us outside of these prize challenges, you can also go on our website at centralfloridatechrove.org. Right? If you want to follow us on socials as well, we're on LinkedIn, Instagram, all the social media platforms as well, right? So that's a little bit about the Tech Rove. So now let's go ahead and let's talk about the actual prize challenge, the 3D surface fuels and vegetation modeling prize challenge. So that's really what we're here to discuss today. When we're talking about the challenge problem, the problem statement, really at the heart of it all is what we're trying to do is solve the big problem of accurate wildfire prediction, accurate wildfire prediction depends on understanding what's happening on the ground, but existing fuel maps often oversimplify or miss critical vegetation and fuel conditions, making it harder to predict how fires will spread and behave, right? So the big problem is predicting, planning, and decision making. And some of the gaps that we see, right? We can account for canopies and trees and stuff like that, but the fuels that are on the ground or that are covered are quite often some that go undefined, right? And we're talking about surface fuels beneath forest canopies. We're talking about shrubs, leaf litter, and woody debris. We're talking about fine scale vegetation patterns that influence fire spreading. But at the heart of everything is really, if you can't accurately predict how a fire will behave, you can't accurately understand what's fueling it, right? So let me say that again. You can't accurately predict how a fire will behave if you don't accurately understand what's fueling it. And so we want to make sure we understand what's fueling it. So how do we go from where we are right now to where we want to be? The real opportunity lies in creating better data, right? Better data, higher definition data, so that it'll enable better decisions. Right. So the goal here is to really develop innovative approaches that create realistic, high resolution 3D representations of vegetation and fuels to improve wildfire planning, response, and decision making. Right. So we want to improve that decision making, the planning, the response, and some of the outcomes that we're looking at, that we're looking for, are more accurate characterization of surface fuels and understory vegetation, high quality 3D fuels data for fire behavior modeling, scalable approaches that can be applied across diverse ecosystems, and then ultimately better support for wildfire response, prescribed fire, and land management, right? So we want to create better data to enable better decisions, and that's really where you come in, right? Your innovative solutions. How we get there really determines on the solutions that are submitted over the course of this prize challenge. And so we're looking for your help and your assistance in making that a reality. So we're really excited. Our team here is really excited to see what you're able to come up with over the next couple of weeks and months. Okay, so an overview of the challenge process. So the prize challenge process is pretty straightforward, but there's a couple of keys to success or a couple of best practices that we want to make sure that you keep in mind as we move forward. And first one sounds very simple, but it's certain elements are often overlooked. So we want to make sure that every single team that participates make sure to read the challenge page thoroughly. If you haven't had a chance to visit the challenge page, you can do so on our website at centralfloridatagrove.org/prize challenge. And then from there, you'll be able to find the 3D Surface Fuels prize challenge link and go right to that page. You'll be able to see all of the information, including the prize challenge overview, the timelines, the evaluation criteria, links that you might need for background information. Everything that you need is on that challenge page. So first step is please make sure to go ahead and visit our website and review all of that. The second thing that we want to make sure that all teams are doing is that they're reviewing all the challenge requirements and technical specifications. Okay. There are certain things that we're looking for and that we've outlined specifically for this prize challenge. And if you go to the how to enter and the judging sections on the challenge page, you'll be able to find links that are going to be helpful for you. That'll provide some background information. You'll be able to see the matrix that outlines exactly how all teams will be scored and all submissions will be scored. So you'll be able to see the evaluation criteria. You'll be able to see all the key dates that apply. And one of the key dates that you definitely want to keep in mind is July 20th. Right, July 20th is going to be the submissions deadline. So if you are not already aware of that date, please make sure that you write that down. And don't worry, I'm going to go ahead and go through the entire timeline in just a few minutes. Step number 3, note all key dates and deadlines. So I just mentioned the number one key date that you want to remember, July 20th, and specifically 11:59 p.m. Eastern time. That's when our submission portal closes. So you have from June 3rd, which is when we kicked off uh, our prize challenge, to July 20th at 11:59 p.m. Eastern time to go ahead and submit your solutions. We're also going to go through an entire timeline and show you exactly all the dates from step one all the way to the final phase of the prize challenge. And we'll do that in just a few minutes. But make sure that you note and place in your calendar all of those important dates that you need to remember. Step four, assemble your team and prepare your submissions package. Okay, if you haven't already done so, go ahead and do that right away. All right, obviously time is on your side or it can be against you if you wait too long. So please make sure that you're preparing on time and you're giving yourself enough time so you don't run out and miss that submissions deadline. And then step five, make sure that you're submitting appropriately. So we have very specific instructions on the type of files that we accept for this prize challenge. So we do accept video links. And normally the best way to submit the video links is unlisted YouTube links. So you upload your video to YouTube, leave it as unlisted, and then you can submit that link to us. We also accept PowerPoint and then PDFs. Those are the different file formats that we accept. You can embed your video links inside your PowerPoint deck or inside your PDF files. All right, whatever works best for you. But those are the file types that we accept. If you have any issues submitting, or if you have any questions as we move through this process, right, that we're not able to answer today or that come up along the way, we do have at the bottom of our challenge page, we have a contact form, right? And in that contact form, you can reach out to us. We usually, have a quick turnaround within 24 hours. We'll be able to go ahead and answer most questions. If they're more technical in nature, then we may have to get them over to one of our subject matter experts, and then that can take a little bit longer, but normally not more than 48 to 72 hours at most. We know that there is a time crunch, so we try to get you your responses as soon as possible. Okay, but for any questions that you need, we have that contact form at the bottom of the challenge page. You can always reach us there. Okay, and to answer that question that was in the chat, all questions and answers will be added to the section in the challenge page that is titled the additional links and resources. So all those questions and answers will be put into a frequently asked question format. And so you'll be able to review those and reference those. I'm also going to put in the link to this recording in the additional links and resources, so you'll have that as well. As we move forward, there may be other resources that we add in here for your benefit. So please be reviewing that regularly as we go forward. All right, key dates and deadlines. So here, if you want to take a screenshot, if you want to take a picture of the screen, you can. This is already on the challenge page, but it doesn't hurt if you want to go ahead and have this for your reference. So 5 key dates that you want to remember here. Number one, the prize challenge launch. It opened last week, June 3rd. So that was the official day that we're accepting submissions. The next and most important date that you want to remember is July 20th. 11:59 p.m. Eastern time. That is the last day to submit your solution. All right. So circle that one, write it down, set reminders. Okay. July 20th is the submissions deadline. Okay. From there, the next important date that you'll want to remember is July 30th. Okay. And that is when we're going to be notifying finalists of their move to the next phase of the competition, which will be the demo day. All right, the in-person demo day. So based on the submissions that we receive, our judges will go ahead and do their evaluations and their down selects. And then once those decisions are made and we have our list of finalists, we'll go ahead and email those finalists the information that they'll need for the next step of the competition. Okay, so if you don't get notified or if you don't receive an email, that you are eligible to participate in the next phase of the competition, unfortunately, you were not selected. Okay, we're only going to reach out to those teams that are moving on to the next phase. Okay, next date that you want to be aware of, August 12th. That is going to be the final demo day deliverables, right? So we're going to have some other adjustments that are going to be made to your submissions, and we're going to outline those when we notify you if you've made it to the next round. We'll be letting you know if we're going to need some adjustments to your PowerPoint decks or to your videos or to your files that you've submitted. And between July 30th and August 12th, we'll need those materials resubmitted. So August 12th is a date that you want to keep in mind if you are advancing to the final demo day. All right. And then finally, the final demo day will be held here at the Central Florida Tech Grove on August 19th, 2026. Okay. So all the finalists that are selected are going to be doing in-person demonstrations here at our facility in Orlando, Florida. You're going to get to do one-on-ones with the judges, Q&As, and demonstrations of your solutions. And that is going to be an in-person event. So there may be travel involved for those of you who are, not here locally in Orlando. All right. So August 19th will be the final demo day. Okay. So just to review some of what we covered, July 20th, 2026, all submissions are due. No late submissions are accepted. All right. So that's firm. That's a firm date, firm time. So please make sure you get those in on time. July 30th, we will have the finalists selected and notified. We're going to have all the information that they'll need for their final demo day deliverables, as well as information on the demo day and exactly what's needed for travel and for your demonstrations. Okay, those finalists will be selected by the assertive judges based on the evaluation process that we go through for all submissions. Okay. August 19, 2026, final demo day. That's going to be held here at the Central Florida Tech Grove, where finalists will showcase their solutions live to all the judges. Okay, and then the awards. So the awards will be first place, it'll be a prize of $40,000. Second place will be a prize of $25,000, and third place is a prize of $20,100. Okay, depending on the amount of finalists that are selected, we only have prize money for first, second, and third place. So there may be teams that do decide to attend that are not eligible for a cash prize. So I want everyone to keep that in mind as we go forward. Okay, so that's what I have for you regarding the prize challenge process, the key dates and reminders, the problem statement, all of that stuff. That is what we have to cover on our end. Most of this information that we covered, almost everything that we covered today is already written in the challenge page. So centralfloриdatechgrove.org/prize challenge, and then go to 3D surface fuels, and you'll be able to access all of the information that you need, all of the criteria, all the links, and then the ability to actually submit your solution by clicking on the Join the Challenge button. Okay, so questions on anything that we've covered today, and also for members of our team, if you have any comments or any information that I didn't cover specifically that you want to share with the group, we can definitely open that up right now. We can go ahead and open that up to the forum for questions. For attendees who have questions, if you want to go ahead and leave your questions in the chat box, or you can go ahead and unmute yourself and share. That's perfectly fine. Any questions on anything we covered today? Brian, so does any source code need to be submitted? I don't believe we need to submit any source code. Would any of the subject matter experts like to weigh in on that regarding the source code?
Well, I don't think the folks that would be able to answer that on the phone, because I see some of the other ones that are on for the SMEs, we're mostly the end user, the folks processing and reviewing that data.
Okay. Inga, did
Inga
you have
has.
a response?
Yeah, I would say one of the advantages of characterizing fuels in this manner would be that it's that WUI area has always been a challenge, right? And so there are, because of the 3D nature, it's more um tailored to be able to cross that boundary into the structural environment. So yeah, I would say it's a I don't know if we would look more favorably, but it's definitely something that we're thinking about, if that makes sense.
Appreciate that, Inga. Do any of our other members of our team want to weigh in on that? Okay.
Yeah, no, I'd have to agree with Inga. I think the problem as an implementer uh, is that issue of us when we're modeling, we often model for outside of our units because those are the units, that's where we have to look at if should we get an escape or something happens there. And so that WUI is an interesting space for us because of the, well, I jokingly call the houses or structures 100,000 hour fuel sources, but uh, that does become a different issue because then we have to see how that not only impacts our response, but how the fuels would respond. So yeah, that I would agree with you by just adding a lot of extra mumbo jumbo there. Sorry, folks.
No worries, appreciate it. Thank you, Brian. Does that help you out a little bit? Okay, great. And then Jeremy had a question here. He wrote in, the challenge highlights the characterization of fuels on and near military lands. Will the judging panel look more favorably on solutions optimized strictly for deep wildland environments? Or are you equally interested in workflows that model the complex wildland urban interface where military boundaries interact with civilian communities? All right, so what do we think on that one, guys?
All the above.
All right, all of the above there, Jeremy. Appreciate that, Tim. Thank you. Okay. All right. Any questions? Any other questions from any of our attendees? Okay, and Brian wrote, is there sample TLS, ALS inputs that we should run against?
Have we gotten that far, Will? I don't know we did. I mean, when we look at it from an end user product, not all, and this is speaking particularly for federal agencies, non-Department of War, we don't all have TLS or ALS, although we are having access to more nationally scanned data sets for ALS, but it's not necessarily in our workflow for or fuels modeling or fire behavior modeling when we tend to do our treatments. So I'd be interesting to see if that is something that could be used for that as a workflow for us so that as we move into the future and TLS and ALS becomes more readily available for practitioners. So I don't think it should be something we should leave out.
Okay, appreciate that, Tim. Thank you. All right. Any other questions that we have? And any other information maybe from our team that we think would be useful to share with the group? And remember, if you have a question that comes up, and whether we didn't cover it here today or it comes up in the future, you can always use our contact form at the bottom of the challenge page and submit it to us, and we'll go ahead and get that answer to you as soon as possible, so we can help you in your effort as you submit. Okay. One last call. Any other
Great
questions?
questions today.
Yeah, very good questions today.
Yeah. So maybe as we have people on the phone, maybe Tim or Inga could give some example. You're just talking about workflows, Tim, and Inga has a very unique background. Maybe there might be some insight that you guys have had through this discussion that you might like to share while you have the opportunity to.
You just put us on the spot there, Sarah. Yeah, I mean, as someone that has been trying to map fuels here for quite a long time, and trying to understand the best way to advance that science and technology and delivery. We're great at the top down, at everything you can see from above. But it really is a challenge to get that bottom up kind of connection. And the way I look at it is, in order to scale the surface fuels and, you know, map larger areas of surface fuels, making that connection with that top down kind of view, I think, is going to be important. Because just, having small areas of data is not going to do it for us. So yeah, just thinking about the potential scaling aspects, I think for me, as someone, that has to map fuels for the entire United States, that's a big focus for me.
And then I'll tag on to what Inga was just saying about scale. So there's two things I would say that I see this. It's the modeling sits in two realms. There sits in the implementation side, where there are folks who are utilizing the tools available to them that do not have the time to invest into a large amount of learning space for that. And so let me try to explain that. So our practitioners have a lot of other things they have to juggle. So for a class example for us, is this expertise in GIS. A lot of our folks tap out at a particular level because there is a lot of extra spatial analysis that goes on into planning, but the implementation side is like Inga was talking, is more of a project level, local. So they're not having to scale out too far for looking at fuels or the tools they're using. And so why I bring this up is developing tools that can be adapted for folks at the planning level who have the opportunity to sit down and really get in and understand how tools function and are able to look at those and they really get in and become experts at them, as opposed to folks who don't have a lot of time. So they need something that can aggregate, adjust, and be applied very quickly, and yet allow them to make sound decisions. That's the thing. We don't want them to make decisions for them. We want them to be able to use their current experience and their expertise to interpret that data. And then the reason why I talk about the planning side is because a lot of our research is shown, and Inga and Nick, you can correct me if I'm wrong on this, but a lot of our research and information that we're getting from their side of the shop is that we need to look bigger. We need to go bigger. We need to plan bigger in order to be effective in some of our treatments. So scaling is very important for us because a lot of us get locked into this project level mentality or mind or view. And so being able to bounce back and forth without having a tool that requires a PhD to use it is very important because the end user isn't implementer. We are people who spend, ideally, when you're at the role who are using the tools that we need to model and go out and do our work, we spend 80% of our time in the field, 20% of our time in the office. That's the end user for that. And so if we had somebody who has to sit and flop that around in order to be able to come up with a product that we can use, that's not viable or efficient for not only the person, but for the agencies. So hopefully that made sense, but I can clarify if needed.
Really appreciate that, Tim. That was great. Inga as well. Appreciate that. Thank you.
Mhm.
Oh, here we go. Question from Molly. Would you say the focus of this data is preemptive fuels treatment versus wildfire modeling?
Both. Because we have so the way it works in the wild and fire world is fuels drive fire. It's the basic of the triangle. So if we are on a fire, a suppression-based fire, our F-bands and folks like that, the people, F-bands being the fire behavior analysis, they're modeling for wildfire behavior in an incident. But from a fuels perspective, when we are treating and looking at trying to reduce hazardous fuels, we are doing this from that preemptive. So we will go out and look for spots on the land and start doing things. Now we have other things that we need to start looking at from that is we have ecological objectives as opposed to, or not as opposed to, in line with the hazard reduction for fire behavior. So we will, and so WUI is one of those classic examples. We always try to look for the ecological solution, but WUI is one of those places we don't always do treatments for ecological outcomes. We do them to reduce fire behavior, to make it so that we can suppress or engage with a fire should one occur there safer.
All right. Thank you, Molly, for your question. Thank you, Tim, for that response. Do we have any other questions? Okay, Brian. Brian wrote in, what is the current method for estimating surface fuels, land fire, FCCS?
That's a loaded question, but I think the quick version is essentially we we use training data such as LiDAR and vegetation plot data to create models of vegetation type, cover, and height. And then we take the vegetation information that we've mapped out, and we essentially have used things like FVS, the Forest Vegetation Simulator. There's a extension on that we've used to estimate things like canopy bulk density, canopy base height, and then we went out to for surface fuels in particular. We went out around the country back in the day when land fire was being developed, and we essentially said, okay, if you have this vegetation type, this cover, this height in your region, what kind of surface fuel fire behavior would you expect? And so it was essentially expert informed back in the day with that information. So things like rate of spread and flame length were the key indicators for which surface fuel model to assign for that type of vegetation and the cover and height that was present. So, and then we also asked them, hey, if this kind of disturbance comes through, how would that change the surface fuel model assignment? So, it really was more about expert opinion in terms of those original assignments and how they aligned with the vegetation information that we had. And it really was like, they had workshops all over the country asking experts to come in. And so it's a different, we'd love it to be a little more data based here in the future, for those kinds of classifications. And then for FCCS, so that was the Scott and Bergen FBFM 40, and the 13. So they're Anderson 13. So there's several classifications. The FCCS was then a kind of a lookup from the vegetation as well. So that was that's more to do with the folks modeling consumption and smoke, and it was more by strata. So it is kind of a little bit more tailored towards this 3D idea, the FCCS classification. But again, it was just that was more, I believe, in that Pacific Northwest lab where, they had mostly scientists involved in that classification. So yeah, that's kind of how those classifications came about. And they're 2D representations of 3D data, essentially. So that, did I answer that? I hope. It's a long story. Landfire is 20 years old, so. Okay, great.
Thank you, Inga, for that long story. Appreciate it. And thank you, Brian, for all the questions. All right. This is great. Any other questions? All right, Jeremy, does carbon credit capture options or community outreach suggestions with the ground fuel map get extra points, or 100% focus on fuel identification and mapping?
I think you're gonna have to write that down and punt that to hires.
Yeah, we can go ahead and get an answer to that. If we don't have someone on the call who can answer it, we'll go ahead and get that answer to you. Thank you, Jeremy. Okay, anything else? Here we go. And then Sarah has a question. Are there specific landfills that are harder to map than others, specific regions that have more or less coverage?
I can take that one. I'll try since I've been quiet. Yes, there's definitely fuels that are more difficult to map than others, especially when you're looking at sort of remote sensing technologies and the sort of attributes of your active scanner. What comes to mind is sort of like rangeland ecosystems as far as those systems go. We know that we have a really hard time, like in the Great Basin, mapping those types of fuels, which like Department of Interior and Department of War are very interested in getting better at. And it's really just, if you think about like grasses, things like that, it's really hard to differentiate in those types of fuel beds because they sort of work together as like a matrix of fuels, as opposed to like an individual tree or an individual shrub. So those systems where we find fuels that are sort of intertwined are really kind of difficult to sort of differentiate fuels. And so we kind of, at this point, are able to identify sort of patches of fuels, but we can't really tell you about the attributes of those patches. So those things are really kind of complicated. I would say that areas where we have sort of consistent canopies, that we're able to map relatively well. But where we have heterogeneity that's happening in the understory that doesn't link back to those overstory attributes, right? So we're not able to sort of infer from the overstory what the understory components are. and those understory components are variable. And so those situations create problems for us. I can also think of sort of management scenarios where overstory canopy has not been affected. And I think this is actually a pretty important thing that we could use these kinds of things for. But the overstory hasn't been affected, but there's been fuels treatments that are happening in the understory. And we would like to be able to describe those fuel treatments. So how much fuel did we reduce? How quickly does that fuel grow back, right? So those types of confounding situations are really where we have a lot of interest. You know, if I'm trying to put a land management activity on a parcel and I want to know sort of how long it lasts and when we're back to the point where we have to go back in there again, you know, it's really important that we understand what the structure of those understory fuels are. As far as coverage goes, I'm assuming you mean like point cloud coverage. I would say that, in my view, sort of ALS has moved from east to west in the United States, right? So in the early days of ALS collection, there was a lot happening sort of with USGS actually doing sort of floodplain mapping and coastal systems and those types of areas. But my general feeling is that we have less of it in the West, which is, you know, sort of unfortunate. But that's if that answers that question.
Sarah, are you satisfied with the response? That answer your question? All right, great, thank you. Okay. This has been a great Q&A session. Really appreciate everyone for their questions. Do we have any final questions or any other questions based on anything you heard here today? All right, in that case. All right, in that case, like I said, if any questions come to mind, you can always reach us on our challenge page. Fill out the contact form. We usually get back to you within 24 hours, or if the question is more technical in nature, it might take a little bit longer than that, but we have a quick turnaround. As I mentioned at the beginning of the presentation today, this recording is going to be available. It's going to be made available to everyone on the challenge page. So in the next 24 hours or so, it should be posted in the additional links and resources section. So we'll have that there for you. I'm also going to take all the questions that we covered here today and add them to our additional links and resources as well, so you can reference them. Okay. Thank you very much for joining us. We appreciate it. And we look forward to your submissions very soon. Thank you, everyone. Have a great rest of your day. Take care.